the last have seen the problem. Given objective function z is equal to 65x plus 45y. Here is the objective function, and in the table machines A, B, time required per unit, bicycles, X tricycles, Y machine A, B, 4 we have given. In this problem, manufacturing tricycles requires 6 hours on machine A and 3 hours on machine B, and manufacturing a bicycle requires 4 hours of machine A and 10 hours of machine B, and availability in hours. $120 for machine A and $180 for machine B. Now we can formulate this problem. The number of bicycles and tricycles is non-negative. That is, x is greater than or equal to 0 and y is greater than or equal to 0. Now one bicycle is required requires 4 hours on machine A, then X bicycles is requires 4x hours on machine A. Similarly, one tricycle is required 6y hours on machine A. On machine A, total requirement of machine A is 6x plus 4y. Sorry, 4x plus 6y. However, machine A of availability is 120 hours. 120 hours. So therefore, given constraint or restriction can be written as four x plus 6y is less than or equal to 120. 4x plus 6y is less than or equal to 120. Means this type of arrow mark. First condition, one bicycle is required 4 hours on machine A, then x bicycles is 4x. Similarly, one tricycle is required 6 hours on machine A, means required 6y hours on machine A. Then total requirement of machine A given machine A is 4x for bicycles, 6y for tricycles, and total availability of in hours for machine A is 120 hours. Then first constraint is for machine A is 4x plus 6y is less than or equal to 120. Now, similarly, one bicycle require 10 hours on machine A. Then X bicycles is required, machine B, and X bicycles is required 10x for machine B. Similarly, tricycle requires 3 hours on machine B, Then y tricycles is required 3y hours on machine B. On machine B. So therefore, given condition that constraint is 10x plus 3y is less than or equal to, here machine B, for machine B 10 hours for bicycles and 3 hours for tricycles, and total number of availability in hours is 180 hours, means here 180. This is a second constraint. Now hence mathematical formulation of LPP can be written as maximize Z is equal to, that is objective function, 65x plus 45y Z is equal to 65x plus 45y means 1. Subject to the conditions that 4x plus 6y is less than or equal to 120, 10x plus 3y is less than or equal to 180, equation second, equation third, where x is greater than or equal to 0, y is greater than or equal to 0, here 4, 5, these are the equations. Then expression 1 is called objective function. We can also written as objective function here. These equations, first constraint 4x plus 6y is less than or equal to 120 and 10x plus 3y is less than or equal to 180, means equation second and equation third is constraints. And x we can see here, x is x suffix for bicycles and y for tricycles, and where both are bicycles and tricycles are non-negativity restrictions, that is x is greater than or equal to 0, x is greater than or equal to 0. Here x is less than or equal to 0 or y is less than or equal to 0 is wrong. Here is no condition. non-negativity restrictions in this formulation, maximize or minimize. X is less than or equal to 0, y is less than or equal to 0 is wrong decision here. Then x comma y is greater than or equal to 0 means non-negativity restrictions. Non-negativity restrictions. This is the formulation of LPP. This type of method is formulation. Now, another example. We can see here. Right, first Z means objective function, 65x 65 rupees for bicycle and 45 rupees for tricycle. Here first constraint 4x plus 6y is less than or equal to 120. Second constraint 10x plus 3y is less than or equal to 180. Third equation x comma y is greater than or equal to 0 is 4 and 5 means non-negativity restrictions. So this method is formulation method. Now another example. Diet of sick person. Diet of sick person must contain at least 4,000 units of vitamins, 50 units of minerals, and 2,500 calories. Here 4,000 units of vitamins, 50 units of minerals, and 2,500 for calories. These are availability. Now, two foods, F1 and F2, capital letters F1 and F2, cost of rupees 50 and 75 per unit respectively. each unit of food, capital F1, each unit of food F1, here arrow mark, contains 200 units of vitamins, two units of minerals, and produces 40 calories. 40 calories. Whereas each unit of food F2 each unit of food F2 contains 100 units of vitamins, 3 units of minerals, and produce 35 calories. 35 calories. Formulate ELPP, to fulfill sick persons requirement at minimum cost. Here in diet problem, a diet of sick persons means ailing person. Sick person must contain at least 4,000 units of vitamins, 50 units of minerals, and 2,500 calories. There are two types of foods, F1 and F2. F1 is cost is rupees 50 and F2 is cost is rupees 75 per unit respectively. Here each unit of food 1 in F1 category F1 contains 200 units of vitamins, 2 units of minerals, and 40 calories can be produced. Whereas each unit of food F2 contains 100 units of vitamins, 3 units of minerals, and produces 35 calories. Then formulation for LPP to fulfill the sick persons requirement at minimum cost. Sick person can be produced at minimum cost requirement. Here is a diet. Now this type of problem, the aim first or the objective function requirement, maximize or minimize. Here is a minimum cost, means minimize. Let X units of food F1, X units of food F1 and Y units of F2, X units of F1 and Y units for F2 be included in the diet of sick person, then the cost, then their cost is for F1 is ₹50 and F2 is ₹75. Then their objective function here ₹50 and ₹75. F1 is 50 and F2 is 75. Then their objective function can be written as minimize Z is equal to 50x plus 75y. Equation 1. This is the objective function. This is a linear function. Linear function is to be minimized. The constraints are follows in table. Here food type, vitamins, minerals and calories. Ingredients. Here food 1, food 2, F2. Total availability. Total availability. Here capital F1 means X and capital F2 is Y. Food 1 is X and food 2 F2 is Y. So here food type F1 and F2 and total availability. Vitamins here given 4,000 units in F1 and F2 can be written as in the table 4,000 units for vitamins. At least 4,000 units of vitamins, 50 units of minerals. Here minerals is 50 and 2,500 calories means 2,500 calories. Now here in this table food type here written food type food for F1 and F2, these are foods, two types of foods. Then we can be written as F1 for X and F2 is Y. And ingredients in this food, ingredients are vitamins, minerals and calories. So first here F1 and F2, each unit of food F1 contains in F1 200 units of vitamins here, right? 200 units of vitamins. 2 units of minerals and produces 40 calories. In calories 40 can be written. Whereas each unit of food F2 means column F2 contains 100 units of vitamins. Here vitamins 100. 3 units of minerals. Minerals is 3 and produce 35 calories. Here 35 calories. Now the formulation. The formulation for LPP can be written as minimize Z is equal to 50x plus 75y. Here equation 1. Given objective function, that is minimum cost requirement. Diet is sick problem, where problem is sick persons dieting. Here Z is equal to 50x plus 75y. Subject to restrictions as here vitamins 200x plus 100y is greater than or equal to 4000, comma. Second, for minerals 2x plus 3y is greater than or equal to 50, comma. And for calories 40x plus 35y is greater than or equal to 2500. Here vitamins, here minerals and calories. These are constants, and where x, comma, y is greater than or equal to 0, non-negativity restrictions. This is the formulation of given problem. Here can be in tubular form, like this. And third is here like this. F1 x and F2 is y, and total availability. And it can be also draw, then we can be should like in this condition. The formulation is minimize z is equal to 50x plus 75y, 1 subject to restriction where objective function first constraint, second for minerals, vitamins, minerals and calories, and non-negativity restrictions, x comma y is greater than or equal to 0. Thank you.